Now let's look at infinite series. An infinite series is the sum of the sequence. So the sum as n goes from 1 to infinity of a sub n is a1 plus a2 plus a3, etc. to a sub n, and then we're going to put this plus and then the ellipses. We're going to keep adding them. Now a lot of times it's easier to discuss the partial sums. The partial sum is simply the sum, so s of n, it's the sum of the first n terms. So this is the sum as I goes from 1 to n of a sub I. Now this is just a dummy variable, don't let it throw you. We could have used m or anything we wanted. So s of 3 is a1 plus a2 plus a3. Now let's talk about convergent and divergent series. For the infinite series, the sum as n goes from 1 to infinity of a sub n, the nth partial sum is s of n, is a1 plus a2 dot 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 plus a sub n. If the sequence of partial sums converges to s, then the series converges, and s is the limit of the series. While if s of n diverges, then the series diverges. Let's look at one of these kind of graphically. Suppose I have a box that is 1 by 1, and I divide it in half. All right? So my first term is 1/2. And then I take what is left and I divide it in half. So I'm always going to be having what I had before. So half of 1/2 is 1/4. Now from the 1/4 I'm going to take half of what's left. All right, so that's this part right here. So this is what plus 1/8. Now I'm going to take half of what's left, and that will be 1/16. Now clearly, if we keep doing this, logically, this looks like the sum has got to equal 1. But let's do it more rigorously. Let's look at the nth partial sums. So S1 of 1 over 2 to the n, which is what this becomes, because we're always cutting it in half, what we had before. So S of 1 is 1 over 2. S2 is 1/2 plus 1/4, and so that's 3/4. S3 is 1/2 plus 1/4 plus 1/8. All right, and this is, we get a common denominator, this is 7/8. Let me extend my page here. All right, so if I look at the nth term, this is going to be 1/2 plus 1/4 plus 1 over 2 to the n. Now if you look at this pattern, remember we were doing pattern recognitions for sequences before, this looks like 2 to the n minus 1 is my numerator. All right, and my denominator is 2 to the n. Now let me look at the limit as n approaches infinity of 2 to the n minus 1 divided by 2 to the n, and that's just 1. And lo and behold, it turns out the sum as n equals 1 to infinity of 1 over 2 to the n is indeed 1.